From the Bode plot of the system with the following open loop transfer function, determine the gain crossover frequency, phase crossover frequency, gain margin, and phase margin, where G of S equal to 1 upon S multiplied by S plus 0.1 S multiplied by 1 plus S. This is the given open loop transfer function. For that, we have to draw the Bode plot to find the gain crossover frequency, phase crossover frequency, gain margin, phase margin. These are the four things we have to find. For that, let us first check whether the system is in time constant form. This is in time constant form. This is also in time constant form. Yes, the transfer function is in time constant form. Therefore, we can take as such factor corner frequency, slope contributed by each factor, net slope, coordinates. So here factor is this is one factor, 1 by S, 1 by J omega. S is replaced by J omega. Corner frequency is nil. Next factor is 1 by S plus 1. Here the coefficient is 1, the corner frequency is 1. Next one is 1 by 0.1 S plus 1. Corner frequency is 1 by T. Corner frequency equal to 1 by time constant. Time constant is 0.1, therefore 10 is the corner frequency. 20 dB per decade. This is also minus 20 dB per decade. This is also minus 20 dB per decade. Net slope is minus 20 dB per decade. This is minus 40 dB per decade. We have to add these two together. If you add all these together, you will get minus 60 dB per decade. Coordinates, the lowest corner frequency is 1. Therefore, let us start with 0.1. We have to find, then for coordinate 1, we have to find the y coordinate. Then for coordinate 10, we have to find, then for coordinate 100, we have to find. For 0.1, this is then log omega, this is in dB. 0.1, 20 log 20 log 0.1 equal to 20 log 10 power minus 1. This is 1 by j omega, therefore minus, because of that one minus 20 log 10 power minus 1, that is equal to 20 log 10 equal to 20 dB. Therefore, the coordinate is 0.1 comma 20. This minus is because it is in denominator. 10 power 0.1 is 10 power minus 1. That's why it becomes plus 20. Therefore, 20 dB. We got the coordinate for 0.1. For 1, we have to find by using the formula y2 equal to slope multiplied by log omega 2 by omega 1 plus y1. y2 equal to slope is up to 1, it is 20 dB. So minus 20 multiplied by log omega 2 is 1 divided by 0.1 plus y1 is 20. That is equal to log 10. This is minus 20 log 10 plus 20. That is equal to minus 20 plus 20 equal to 0. Now we have to find coordinate, y coordinate for 10. That is equal to y2 equal to up to 10. The slope is minus 40. Therefore, minus 40 multiplied by log omega 2 is 10. Omega 1 is 1 plus 0. That is equal to minus 40 log 10. That is equal to minus 40. Therefore, here the coordinate is minus 40. From 10 onwards, the slope is minus 60. Therefore, now we have to find the coordinate per 100. That is y2 equal to, from here, the same formula, minus 60 log omega 2, that is 100 divided by 10. Omega 1 is 10 plus minus 40. So minus 60 log 100 by 10 is log 10, that is 1. Therefore, that is equal to minus 60 minus 40. That is equal to minus 100. Therefore, here minus 100. That's all. Now we have to draw the plot. It starts at 0.1, 20 dB, 1, 10, 100, 1000. Up 10 at minus 40. The slope is minus 40. At 100, minus 100. Minus 100. Here slope is minus 40 dB per decade. Here the slope is minus 60 dB per decade. Here the slope is minus 20 dB per decade. Up to this 20 dB, after that 40 dB, after that minus 60 dB. So this is the magnitude plot. Now we have to draw the phase plot. Angle of G of j omega equal to angle of 1 divided by j omega 0.1 j omega plus 1, that is j omega plus 1, that is equal to minus 90 degree for j omega. For this 0.1, tan inverse of 0.1 omega divided by 1 minus tan inverse of omega by 1. That's all. When omega equal to 0, the table we have to find. When omega equal to 0, omega angle of G of j omega 0, you will get minus 90 because this becomes 0 and this also becomes 0, therefore minus 90. When omega equal to 0.1, you will get minus 96.3, minus 96.3. When omega equal to 1, you will get minus 140.7, minus 140.7. When omega equal to 10, you will get minus 219.3. When it is 100, it is minus 263, minus 263.7. When it is infinity, infinity means this becomes 90, this also becomes 90, therefore minus 270 degree. 270 degree. So the angle varies from 90 to 270. This is minus 270. This is 180. This is 90 degree. When 0, 90, 0.1 starts at 0.1, 1, 10, 100, 1000. This is at 0.1, the angle is minus 90, 96, minus 96, minus 180, minus 96 at 1, 140, at 1, 140, at 10, 219 here, at 1, 219, here 140, here 96, at 100, 263, at infinity 270. So the plot will be like this. Now, where it crosses 180, the frequency at which it crosses 180, the gain crossover frequency is this. This is called omega GC. Gain is crossing 0. That is called gain crossover frequency. Phase is crossing 180 is called phase crossover frequency. So, one gain crossover frequency is 1. At that point, it is 0. Therefore, gain crossover frequency is 1. Phase crossover frequency is where it crosses phase. That is 3.16. This is 3.16. Now we have to find this is Bode plot is approximate plot that we have to remember. Approximate plot. So you will get one approximate value because at 1 there is a it is a corner frequency. 1 is a corner frequency. That's why you will get error at that point. Small error you will get because the Bode plot is not true at corner frequencies. But anyhow, the answer is 1, but it is not correct gain crossover frequency that we will see in simulation. But anyhow, for examination point of view, 1, that is correct. Gain margin at phase crossover frequency, we have to draw a vertical line. At phase crossover frequency, we have to draw a vertical line. It cuts the magnitude plot at one point, draw a horizontal line. Here, you got the magnitude is minus 20.8, minus 20.8. Therefore, gain margin is gain margin equal to minus of minus 20.8. That is equal to 20.8 dB gain margin. Phase margin, to find the phase margin, draw a vertical line at gain crossover frequency. It cuts the phase plot here. Here, what is the angle we have to see? Angle we have to see. Here, the angle is minus 133 point. Therefore, phase margin equal to 180 minus 133 equal to 47.4. 47.4. Therefore, the phase crossover frequency is 3.16 radians per second. At that point, what is the gain? Gain is minus 20.8. Therefore, gain margin equal to 20.8. Gain crossover frequency is 1. At that point, the angle is minus 134. Phase margin equal to 180 minus 47.4. That's all. Now let us see this by simulation. Now let us verify the result by using MATLAB. Let us verify the result by using MATLAB. The given transfer function is 1 upon s multiplied by s plus 1 multiplied by 0.1 s plus 1. If you convert this into polynomial, you will get 1 upon 0.1 s cube plus 1.1 s square plus s plus 0. So we have to enter the numerator polynomial. Numerator polynomial is only constant term. That's all. N equal to numerator polynomial is only constant term. That's all. Denominator polynomial is s cube 0.1 s cube 0.1 s cube. Coefficient of s cube is 0.1. Coefficient of s square is 1.1. Coefficient of constant term is 1. And the constant term is 0. Constant term is 0. Now we have to find the transfer function. Transfer function of numerator, comma, denominator. Enter. So we got the transfer function 1 upon 0.1 s cube plus 1.1 s square plus s. To get the Bode plot, we have to type Bode. We have to invoke the function Bode by passing the transfer function. Transfer function is available in the ANS variable. So we got the Bode plot. This is the Bode plot. It starts at 0.01, that is 10 power minus 2, but we plotted from 0.1 only up to 1000 we plotted. Okay. So this is the magnitude plot. In the bottom it is phase plot. Both we plotted. Now to get the phase margin and the gain margin, we have to call the function called margin. The transfer function is available at the ANS. We call that margin yes. Now the gain margin is 20.8. We also got 20.8. So that this 20.8 is magnitude at phase crossover frequency. That is, it crosses at 180 degree. At that point, it is 3.16. 3.16. At that point, the magnitude is minus 20.8. Minus of minus 20.8 is 20.8. Gain margin is 20.8. Phase margin, where it crosses 0 dB, it crosses 0 dB at 0.784 in MATLAB. But we got 1. This is because at Bode plot is the approximate plot. There will be error at corner frequencies. The error at corner frequency is 1 minus 0.784. That is the difference. That is about 0.2. 0.22. That is the error. Because MATLAB gives the actual plot, Bode plot is the approximate plot at the corner frequencies. That's why this difference. But as far as examination is concerned, we have to write the phase crossover frequency for Bode plot only. That is 1. We wrote 1. The phase margin is 47.4. This therefore phase margin is 47.4. That's all. But if you want to do the necessary correction at corner frequency, that is available in the book. That can be done manually. Necessary corrections at corner frequency so that we will get the exact plot. So, but MATLAB gives exact plot, but we are finding for approximate plot, that is Bode plot. சின்ன ஒரு ரெக்கார்ட் சொல்லுங்க ஜி. ஆமா, இன்னைக்கு காலையில நீங்க வர முடியலன்னு சொன்னாங்க. வந்து இது மாதிரி கொண்டு போய் விடணும், மேடத்தை கொண்டு போய் பஸ் ஸ்டாப்ல விடணும். ஏதாவது ஒரு ஆல்டர்னேட் பண்ண முடியாதா? ஆல்டர்னேட் டியூஸ்டே வரும். ஆல்டர்னேட் டியூஸ்டே இந்த ப்ராப்ளம் வரும். 6 மணிக்கு தான் வச்சிருக்கிறாரு அவர் பிரச்சாரக்கு. அப்படி வைக்க மாட்டாரு. இப்ப காலையில 6 to 7 அவங்க அதுக்கப்புறம் வேலையை பார்க்கலான்ற மாதிரி எந்திரிக்க மாட்டாங்க. அன்னைக்கு மட்டும் ஏதாவது ஒரு ஆல்டர்னேட் பண்ணி விட்டுற முடியாது நீங்க மேடத்துக்கு? ஓ, செவ்வாய்க்கிழமை மட்டும் அந்த 1 hour முன்னாடி போகணும், அது வருதா? இங்கிலீஷ்க்கு 1 hour முன்னாடி. எங்க வீட்டுல வந்து வியாழக்கிழமை. இது இவங்க வந்து இது வரும் இங்கிலீஷ். இங்கிலீஷா? செகண்ட் டியூஸ்டே தான் வரும். அது எதாவது மாத்திக்க முடியாதா? டெம்பரரியா இந்த செவ்வாய் 2வது செவ்வாய்க்கிழமையும் 4வது செவ்வாய். இவங்களுக்கு வந்து வியாழக்கிழமை. செவ்வாய்க்கிழமை ஏன் வச்சதுன்னா அன்னைக்கு எதுவும் ஃபங்க்ஷன்லாம் இருக்காது அப்படின்றதுக்கா அன்னைக்கு வச்சதுதான். நமக்கு கிளாஸ்